My name is James Elliott. I'm going to be talking to you about something that's been devouring my life for the last year and a bit, which I call Afterglow. So I'm a software developer. I work at Single Software with a bunch of other guys who are here. And I also sometimes DJ. And in the process of doing that, I started gathering some entertainment lights because I thought they'd be kind of cool and add a neat element to the shows. And that's a real slippery slope. You start getting a couple, and then you realize, well, yeah, that's neat, but what if I had them hooked together and could control them for real? And then, well, if I've got this control system, I need another couple more lights to make it worth it. And it snowballs from there. But not long after, well, we've been doing shows for about a year or two, and I realized I really didn't like the software that we had. There were a couple things that I thought were particularly flawed in it. The main one was how it worked with other controllers. Like, so, you have these MIDI controllers that give you nice grids for working with your light cues. And we had one of those, and Chris, my partner behind Ryan there, did a really nice job of building a set of cues on that and mapping them to the software that we had. But just because of the limitations in the software, if you touched the mouse instead of the controller, there was no feedback between the two. So it would look like on the controller that it was off, but the computer thought it was on, so you could get things out of sync. It had flaky behavior. It didn't have great user interface. There were some generators you could use to build programmed effects, but they were very limited, and you could only sort of render them ahead of time and then run them. There was no way to synchronize it to music, so you'd have to sit there tapping the tempo and trying to line it up or just guessing. And there was no support for some of the newer lights we had, which in addition to having RGB channels, they had white and amber and even sometimes UV channels. So with all those things, I said, well, this stuff isn't as good as I want it to be. So we were starting to use Clojure at work for a couple of our projects, and it's a really neat language with all kinds of great properties. But then I stumbled across this project called Overtone. I think actually, Ryan, you mentioned that to me. So I went and watched the presentation on that. And what Overtone is it's a music synthesis system written in Clojure. So it takes a really functional approach to how you organize the sounds and how you string them together. And I said, well, wow, if you can do that in Clojure and it's responsive enough to do music and have good timing with it, I bet I could build a lighting control system in Clojure. So that was the start of the slippery slope. And so Afterglow is a lighting control system. It's also an experimental platform where I try out different ideas. It's becoming a growing integration hub, as you will see. It talks to a lot of different kinds of things. And it's spinning off other open source projects of its own. I didn't mention that, but it's an open source project. So a little bit about doing light shows. It's an impractical hobby. This is what our living room looked like for about 2 weeks before we did our last show about a month ago. And let's get this thing running. Coming out the wrong speakers. So this gives you a sense of what our full rig looks like, since I didn't have room or time to set that up for this show. But you'll see that light there is one of the ones you see on the rig. That one's one of the ones down there.
What does the cat think of this?
He's kind of used to it.
It just seems like, a little laser pointer goes, cats go nuts.
These are all LEDs?
Yeah, these are LEDs. Mm-hmm. All right. So given that, a little bit about what tonight is not and what it is. So what this is not an actual performance by Deep Symmetry. This is not a full-blown light show. We don't have a DJ set to play for you. We don't have fog, which is really nice for adding atmospheric to the effects of the beams of light moving around. We don't have most of our lights and lasers. We don't have a dance floor. And we don't have Blur. Well, actually, I hope there is. Those of you who are not familiar with the electronic music scene, Blur stands for peace, love, understanding, and respect. It's one of the things that people like to foster at a lot of electronic music events. So hopefully, all of our Clojure meetups had that anyway.
I want my money back.
All right, I'll give you all the money back.
Yeah, full refund.
So what is tonight? Well, it's going to be an introduction to many of the cool building blocks that go into our show. I'm going to start with some of the underlying technologies and how I use them from Clojure. A technical exploration of what we use, and one really fun use of the Clojure environment. All right, so before I begin, any questions? Okay. So these lights that you see here, which I haven't powered up yet, and I need to do controlled using a protocol called DMX 512. And that stands for digital multiplex. And it's a fairly old protocol. I think it's been around since the 80s. But what it gives you, it evolved from the big banks of theatrical dimmers that you'd see if you went behind stage at an old theater with these giant levers that you could use to move huge rheostats and bring up and down the lights that were hooked to different channels. So this took that and put it into a single cable that string in a daisy chain fashion between the lights. Each cable can carry 512 channels, and each of those channels can have 256 different levels. It doesn't carry the power, it's just a signaling protocol. And each one of those channels can be, well, it started out just being brightness, because that was all I used to do. But then people started building fixtures that had more fancy features. So it might be you have 3 channels for your red, green, and blue brightness, and maybe a separate channel for your dimmer that overall adjusts the light right up and down. Or it might just pick a color. That light there, as I'll show in a little bit, has a color wheel. So depending on the value of the channel, it spins to a different color. It might change the focus, what the light is aimed at focus-wise, or it might rotate the light, or it might pick a template, or some other kind of special effect. So when you assign the light, when you hook up a light, you give it an address. So you'll see the 285 sitting on the base of that one there. That one is listening starting at channel 285. Now it listens to more than one channel. It's got a bunch of different features, so it listens to, I think, about 16 or 18 channels, but starting with 285. So with each of these channels, 40 times a second, which is the typical refresh rate, you can send a new value for every channel. So in order to make a light show happen, all you need to do is spew out a whole lot of numbers very quickly. All right, that's it. Yeah. So I didn't have to write the software to talk DMX directly myself. There's a really cool open source project called the Open Lighting Architecture that I use. And it talks to a bunch of different hardware. What I'm using tonight is this thing called an NTEC DMX USB Pro. It takes a USB connector on one end and feeds out 2 universes of DMX on the side. It can also speak over Ethernet or other similar networks using a protocol called ArtNet, or a more modern one that our friends at Electronic Theater Controls in Middleton define called SACM1 or ELM1. They also have images for Raspberry Pis that run their software. So if you don't have, it doesn't run in Windows very well. So if you're stuck with Windows, you're recommend you buy a Raspberry Pi to run it on. And then it has a daemon, which responds to remote procedure calls using Google Protobuf, which is a pretty neat binary protocol. So I wrote a closure binding for the Open Lighting Architecture, and then at the request of the Open Lighting Architecture people, I spun that off into its own open source project called OLO Closure. So let's pop out of the slides for a minute and look at the OLO daemon. It has an embedded web server, which we're looking at here. And so I've got a couple different universes running right now. I'm actually running 2 universes to those lights up there. Everything except for that white strip is running on one, and that white strip is a brand new light that I just got for this demo because I wanted to talk to Bill about pixel mapping, so you guys gave me an excuse to invest. And let's look at universe 1, which is what most of the lights are connected to. If I go to that one and go to the DMX console, I happen to know that moving spot there is starting on channel 1. So if I fiddle with this fader here, you can see it makes the light turn around. So that channel controls which direction that light is aiming. Now it's pretty fidgety, and this is a hard way to control it. Even moving it a little bit moves it for a bit. There's a second channel that is for fine positioning. So if I move it all the way, you can barely see it moving back and forth. And then similarly this adjusts the tilt level. All right, and let's see. Let me jump over to the light for a moment, and we'll come back to this one. So I know that 187 is the dimmer for that tallest light there. So I turn that up, nothing happened. Why is that? Well, because in addition to having a dimmer, it's got individual red, green, and blue controls for each of the heads that are on there. So this next one is the red channel on that head. So as I adjust that, the red gets brighter and dimmer. And if I add a little bit of green, you can make yellow. And then the main dimmer will dim the whole thing. So then this is the red channel for the next one, and so on. So that's how you can put together different colors on different heads for these lights.
Can you go through the whole spectrum with those?
You can. Yeah, I'll be showing you that later. That's a lot easier to do once you've got Afterglow running, because it'll do the calculations for you if you give the hue what the red, green, blue values are that you want to put out. All right. Let's jump back to channel 1. I was going to show you a couple other more things on the torrent before we move on. Okay, so channel 9 is the shutter for the torrent. So like an old light would have a physical shutter, this is just an electronic one. So that didn't seem to do anything, but if I turn up the dimmer, you can see that there's some light coming out of that one now. So in addition to being open or closed, the shutter can do things like strobing. So there's a fast strobe, or it can do different kinds of throbbing patterns. It's really finicky to try to adjust these things by hand, which is why you end up writing button control software.
Or why you end up writing.
Yes, yes. Okay, so that I mentioned the idea of focus. Channel 11 is focus for this particular light. You can kind of see that. Nice crystals there. And why do you want to focus that? Well, we'll show you more in a moment. Let's go back to my concept of color. So channel 5 is the color channel for this. As I crank this up, suddenly it's red. So you can see the color swooping in there. It's a wheel inside that's just moving to present a different color. And if I go high enough, it starts spinning the wheel. So let's just go back to the right. And
So is there an actual physical wheel?
yes, there's actual physical wheel in there. In addition to spinning the color wheel, channel 6 is a goer. And that lets you put patterns so you can have multiple colors in them like that. So that's one of the gobo wheels. And again, you can make it spin or shake. Someone was asking me earlier about having seizures. And I don't see you morning, so yeah, we should perhaps warn that. No, wait, channel 7 is, oh right, that's the rotation of the gobo. Let's go back to the gobo. Oops. This one's fun. And then when there's a gobo in place, channel 7 will work here. And then channel 8 is another gobo. So let's pull this one up so we can see it. Now that one looks really blurry because they're in different focal planes. So you would go back to your focus and bring it home to focus. So you can combine gobos, you can focus back and forth between them and do all kinds of stuff. And then before we go on to demonstrating the other software, I will show you the prism. Let's focus that a little bit more. So what's a prism do? Well, in addition to having all these other things coming and going, if we bring up channel 12, we can add this prism which divides the beam up into 3. So you can have multiple copies of the thing, or you can even make it spin. So combining all that stuff, as you can imagine, which will be easier to do after is how you build up really interesting looking looks. So that is just using the lights raw via DMX. So let's look at how you do it with closure. So there's a couple of concepts we're going to look at tonight, and I'm going to introduce them now, and then I'll show you them in action, and then we'll go back and talk about them at the end of it. First of all, there's this thing called the fixture definition, which is telling Afterglow, how the heck do I control that light or that light? It needs to know what the channels are, what the values of those channels mean. Sometimes they have subdivisions within the channel that do different things. And also, Afterglow does more modeling of the lights than any other lighting software that I know, because it models physically how the light moves in response to the different control channels. So I've told it where in space these lights are, and I can tell it I want to aim at that point on the ceiling, and it will do the trigonometry to figure out how those lights have to be pointing, and then it'll do the math to figure out what DMX values to send to those lights. It's actually an optimization problem in robotics, because there's several different combinations of values you can use that'll point in the same direction. You want to get there with the least movement from where you are now. So those are fixture definitions, and those are just closure maps in the end. But you generally, there's a function that builds the map because you can have different parameters. The lights have different modes they can be in, things like that. Show space, in order to be able to think about space like that, it has a notion of where the origin is. The origin is on the floor, right between the center of mass of those two lights that are sitting on the edge of the table. And the z-axis extends out into the audience, back negative behind them. The y-axis goes to the ceiling and down to the floor, which is 0 at the floor. And then the x-axis goes this way, so positive that way, negative that way. So that's how you express where the lights are and how it figures about where to aim things. Okay, now we're dealing with music, so that involves time, and so there's a metronome that has a really fundamental role inside Afterglow. It has a notion of how many beats per minute are going on, and it also knows how many beats per bar you've got, and then how many bars per phrase, because electronic music is often divided up into 8-bar phrases of 4-bar beats, and so if you have your lights build to a climax at the right point in that phrase, it looks really nice with the music. In order to do things that look interesting, you're going to want to have the lights change over time, so you have oscillators for that. We'll talk more about those later when we can actually see them. And then to do things like colors that change over in space or in time, we have dynamic parameters that can be fed by oscillators, or can be spatial, or a combination of both. And then you, of course, want to have variables you can stick things in to have your cue based off of those. Building on those, you do effects. What's an effect? It's a look on the lights. It's, I want these lights to do something. We'll talk more about that when we have a chance to see them. But basically, well, yeah, we'll talk more about that. Effects, we spit out assigners. Assigners do things to lights, and there's a rendering we'll talk about once we've seen a bit more. Kinds of effects, dimmer, make the lights brighter or dimmer. Color, make a color happen somewhere. A spatial effect aims in a particular direction or a particular point. A function effect can do something like pick the gobo that looks like biohazard symbol, or strobe, something like that. And then compound effects, you build other effects with. All right. So how do we see all these things? Let's look at our friend, the Clojure REPL, to begin with. So here we are in Emacs. I think the first meetup I saw here at Universe was how do you use Cider in Emacs with Clojure, and that's my favorite environment as well. So that's my project definition, and I just fired up the REPL before things started. And to get things going, I'm going to say use sample show, which creates a bunch of lighting fixture definitions and whatnot. And I'm going to be done. And I'll say show start. And when I do that, you're going to see that immediately, the lights are going to go back to their home positions, because right now Afterglow is not interacting with OLA, but as soon as I say show start, it's going to start blasting out its frames of DMX information 40 times a second. And since there are no effects running, it's going to set everything to 0. So the lights are going to go back to their defaults. Yeah. All right, so let's make something happen. Well, I have a... That's not supposed to be oh, I know. We're having battling lighting codes. Ola was still running and sending its frame, sending its values.
It's getting 41 per second.
No, this. It wouldn't be a demo if something didn't work. But not quite right. Okay, so I wrote this little cheat function, and this is, I'm sort of walking through the README on the GitHub project at this point, which is how to get people started with this. So fiat lux means make light in Latin, and that's what it does. So it creates a slate blue color effect, and it applies it to all the fixtures that it knows about in the show. So that's at full brightness. So if we wanted to control the brightness, we could add another effect. And we'll do this one sort of by hand. So add effect is one of our options here, and that's one we want, the effect. When you add an effect, you give it a key, which is how you can refer to it later if you want to stop it. And it also lets you group them so that they can be mutually exclusive. And what do I want to have my dimmers effect? Well, also a global dimmer effect. And level 100. So that's going to be a little bit less than half, so things will get dimmer. And things get dimmer. Except for that one. That new one I was talking about with all the LEDs on it that takes up its own whole universe. That one doesn't have a dimmer. So a dimmer effect has no effect on it. And this was something I hadn't encountered myself, but there was a guy in Russia who was exploring Afterglow to use with his band. And he said, well, I have these lights that don't have dimmers, what do I do? So I thought about it for a while, and I created something called a virtual dimmer, which, let's see. I will just do it. So, yeah, there it is. Add virtual dimmers. Thank you, Cider, for reminding me about the virtual dimmers. So if you pass that with true, keep your eye on the that one big LED bar, and you'll see it get a little bit dimmer at this point. I can never do a key. There. So what the virtual dimmer does is it creates a color effect that takes the output of the other color effects, runs after them, and acts as though a dimmer has been applied to it. So it reduces the RGB values as though there was a dimmer on the light. So that becomes important in lights like this. Okay, so that's a dimmer effect, a color effect. Let's look at quick. Global color effect takes a keyword that you can pick a color with.
Bang.
Oops, thank you. That trace. That's more orange.
That is more orange.
And then let's look at an oscillator quick. So we're using the oscillator namespace to build an oscillated parameter. And I'm going to use a sawtooth wave, which just does a rag. And we will include our virtual dimmer so that it applies to all of them. And there we go. So now we have an oscillator that's running in sync with the metronome. And it is wrapping up the lights once on each beat.
So when you run that add effect with the same keyword, does it replace the old
Exactly.
one?
It replaces whatever else is running with the same keyword. So if we want to change the speed of that, we can just affect the metronome. So I'm going to set the BPM. Metronome keyword attached to the show variable. And it's right now it's at 120, which is the default. So if we drop it to 70, things will slow down. Yeah. All right. Well, and as you can see, you could run a light show like this, but it's not going to be all that practical. So how would you really do it? Let's first look at the web interface. So the start web server thing, and if you run Afterglow as a jar, it starts out with this on by default. But I'm going to tell it to listen to port 1600, and I want to open the browser, and there it is. So this is a Luminous web interface, those of you who built Clojure web projects before. And the main purpose of it, well, I mean, you can hop in here and type Clojure expressions if you need to, and you haven't got a REPL handy. But the main point of it is this show control interface here. So what you're looking at there is a queue grid. That's an 8x8 grid, and those queues are designed to run effects when you click on them. The colors are all designed to be sort of mnemonic. You can assign any color you want to a queue. And some of them, as you can see, are changing color, and those are sort of trying to represent the fact that the queue itself changes color. So let's turn all the dimmers on. That took over from the other dimmer queue we had running because they have the same name. So that's very similar to what we had going on before. Let's speed up the metronome a bit. This is a lot easier than expression. Okay, now, what did I want to show on this one? Okay, yeah, everyone likes strobes. So these strobes are another...
Oh, not everyone.
But that gives you a sense of how you could really show. You can pick the different texture groups and strobe them. And I'll show you more things about that when we're talking about physical controllers. And there's, like I said, there's relationships between effects. So notice how a lot of these things get dim when I click this all saw. That's all the other dimmer effects for any fixture dim themselves to say, hey, if you run me, it's going to kill that other one because they're mutually exclusive. Now, if I just did it on torrent, that only dims the column of effects that are affecting the torrent, which is that fixture on the right there. So I could also do a different dimmer effect on that right. That would be conflict. So that visual relationship between the queues is a nice thing to be able to see. There's more queues than can fit on the screen, so you can scroll through them by using these things here. So let's look at a very different kind of light that's been just kind of sitting there quietly up until this point. This guy is a little laser. And let's turn it on. Now, one thing I haven't shown you here is while these things are running, each effect has a row in this table down here show you that it's running. You can edit down there. And you can also, if the queue has variables associated with it, there's a web interface for adjusting them. So this is the speed that laser is rotating. And you can adjust it there. Or similarly, that like there we can make it go slower or faster by adjusting these things. All right. Oh yeah, one more thing before we move on. Let's go back over here. Let's just make it not so crazy. We'll go back. So these are color cues on the bottom here, and that's a white. No, let's turn that to Grandmaster. This is basically all the dimmers are routed through this Grandmaster, so if you turn it down, it scales down all the dimmer effects by that amount. That was another thing our other software wouldn't do, and we were in some small rooms where these lights were just too overpowering. But you can turn down the brightness of the whole show using this Grandmaster concept in there. So that color effect I've got running is defaults to white, but you can pull up a little color picker here and pick your color. And then it also shows in the that happens sometimes with that. That's another open source component I'm using for the color thing. I'm going to reload the page. It gets flaky sometimes. Okay, so there. Oh, yeah. Okay, so now the queue shows that color while it's running. If I end it, it goes away and goes back to being the default color of white. But if I go in here and make it green, and say save, now it remembers that. So I've just basically saved that as the default color for that cue from that point on, which is a handy thing to be able to do running a show. All right, I'm going to show you a little bit with the torrent again so I can see macros, and then we're going to move on to the next fun topic. All right, so we'll go over here, and let's start by aiming this gun. All right. Here. And let's do a cool effect. So let's say we've got and simultaneously sunflowers. So those are two different gobos there right now, and you can't really see them at the moment because either's in focus. But if we change the focus, you can sort of go back and forth. You can go back and forth between seeing that one and that one. So that's kind of cool going back and forth like that. Well, let's make it do it by itself. So I can do a focus sign, which is another cue that I've built that goes back and forth between the two focus points. That actually is not too bad there, but it's a little extreme. So let's not quite go up to 100 and not quite go down to 0. So that looks pretty cool. That's almost a nice lighting effect on its own. But let's throw the prism in, make it spin some. So if you had some fog going and that was going around the floor, that would be a really nice lighting effect. So, but it took me a fair bit of effort to put it together. Well, that's what macros are for. So if you go down here and say make macro, it adds these little checkboxes to all the effects, and you can pick the ones you want to include. So that was the two gobos, the focus sign, the prism, and aiming the torrent. So I'll go down and say sunflower, squirrel. And then all I have to do is pick somewhere in the key grid where I want it to be, so I'll say there. Suddenly I've got a new cue. So if I hit it again and take it over, you don't see anything because I was doing the same thing I was doing before, but now it's stopped. But if I ever want to have all those things come back again, I just have to hit this one thing and then boom, there it is.
So when you save that, does it go into a config file for use later, or is it just into the live REPL session?
Macros right now get written to a file as closure expressions, and you can edit them into your show definition later. Okay. I'm planning to throw a database in here at some point, but I haven't needed it yet. So I apologize for this garish continuity error, but the camera stopped working at this point during the presentation, and we didn't notice it for a few minutes, so I'm going to have to reconstruct this segue in my home rehearsal space, also known as the edge of my kitchen. So we were looking at the Afterglow web interface, and that was clearly a big improvement in terms of expressive power and performance ease compared to a raw closure REPL, but it's not everything you might want. For example, even if you're really quick with a mouse, you can only click one cue at a time using the web interface because there's only one mouse pointer. There are other things that you might want to do more expressively, and for that, you really want to turn to something like a MIDI controller. In fact, I happen to have an Ableton Push, which is an incredibly well-designed MIDI controller, which Ableton created to use with their live digital audio workstation software. It's got this big grid of pressure-sensitive pads, which you can press multiple ones at the same time, and also it can tell how hard you're pressing them. It's got a beautiful text display here, which can convey lots of information, and these touch-sensitive encoders, which can react as soon as you touch them to update the interface and then give you feedback as you're doing things. So I'd love to be able to control Afterglow with something like this. Ableton documented some aspects of the push, but the fact that it worked entirely with MIDI meant that you could use a program like MIDI Monitor to watch all of the communication between live and the push and figure out exactly how it worked. So Afterglow can be used with any kind of MIDI controller that you might have around, including just incredibly inexpensive ones. You can map buttons or knobs or whatever on the controller to trigger cues. You can map faders and knobs and encoders to adjust cue variables. But if you happen to have a really, really awesome controller like a Push around and you've configured Afterglow to watch for it, as soon as you plug it in, Afterglow will notice and bring up the custom interface that I created for the Push on it. In fact, I actually started working on this Push interface even before I started the web interface. So here's what happens when you connect it. Gives you a little gratuitous starting animation that I just couldn't resist putting in there, and shows you information about the cues up top there and the cue grid there. And at this point, we can actually teleport back to the demonstration that was already in progress because the camera is working again. And when we did that, this little menu appeared on the screen here, linked controller. So if I choose Ableton Push, now everything, this cue grid that you see on this is tied to the cue grid that you see on the screen there. So if I scroll around on this, it scrolls that around as well. So that lets you see what cues you're looking at on this, and then you can actually hit them on the controller. Now, one of the things that is immediately nice about that is you can say you want to stroke torrents and other systems. You can hit both those at the same time. But what's also really cool about these controllers is that they're pressure sensitive. So the harder I push it, the brighter, the more intense the stroke is. Or you can do other completely different kinds of effects. Like this one I call bloom, where it's going to grow a little circle, and the harder I push it, the bigger the circle gets until it spreads all over the whole light grid. So, so let me just show you a couple more things about this controller, and then I'll tell you a tale of woe. So you can adjust the metronome here too. You can change the BPM by turning this. You can say what beat you're on by this. You can tap your tempo out. So it's easier to do it there than it is on the mouse. But along the top here, you have the list of effects that are running, and you can adjust their cue variables as well. So this is the Grandmaster here. As I turn this, you can adjust the brightness of that. Or if I here's the intern part one, guys. So I can adjust parameters of the cues there as well. And if you've got a color cue going, which I don't think I do at the minute, but I can bring them up quick. Bring that one up. Oh no, that's a rainbow cue. Oh, I forgot to show you those. Actually, that won't be clear. We'll get back to those. So that's the green cue. So if I've got this green cue running, it's right here. I touch one of the decoders. It gives me a palette here on the screen, so I can pick a color just by pressing one of those buttons, which is another nice way of picking it. And then I can adjust the saturation by turning this. I don't know if you can see this little bar graph that's showing me what the saturation is. And if I had scrolled up over here, you'd see that it was. Oh no, it wouldn't, because it's just showing the color there. So those are really nice features. You can also adjust the saturation or any other variable by using this touch strip here. And just about the time when I had finished getting this interface implemented and working really nicely on the push, Ableton announced the push 2. And they had this big program where they would take your old pushes and give you a huge discount on getting a push 2, and then they were given to schools for working with and whatnot. And there was no real documentation on the MIDI interface for this thing. We figured it out ourselves, but the reason we were able to do that is it talks purely MIDI. And there's tools, there's a program called MIDI Monitor where that you can run on your Mac that shows you all the MIDI messages going in and out. So you can watch while Live is controlling this thing and see the MIDI messages that are going back and forth and figure out what does what. So that was how we figured out how to make these things do this cool stuff. Even the display, that text area, those are MIDI system explicit messages. It just sends a big wad of bytes that set the display. I borrowed a push 2 from a friend who was at the local Ableton rep, and bad news. The display was not showing up at all in MIDI. They were both, the display was the brand new feature at the push 2. It's a beautiful RGB monitor, basically, built into the thing. MIDI doesn't have the bandwidth for that. So I was like, I'm never going to be able to figure out how to reverse engineer that. So I had this orphan lighting control system on a hardware platform that was just killed. So in response to that, I decided to spend a little time working with innovation. These guys they aren't nearly as fancy as the push overall. They don't have displays at all, or the touch-sensitive encoders, but they have the nice pressure-sensitive grids, and they have the advantage of having documentation. And not only that, but they sent me some hardware so that I could map their whole line, which was pretty cool. So you can have multiple controllers running at once with Afterglow. We've got both the push and this running, and that menu now has both of them in it. So you could have this one looking at one part of the cue grid, doing things, that one looking at another part. You can even open multiple web windows and have each of them tied to a different controller if you have a lot of screen space. It's kind of nuts. So that one tied me over. But then, right as we were about to do our last show, one of my friends said, hey, have you seen what Ableton posted on GitHub? And lo and behold, they had open sourced a bunch of really good documentation for the push 2. And so I, of course, immediately had to get one. So let's switch.
You should see the boxes that show up at single layer.
So the way that you control the display on the push 2 is via USB as well. There's a USB serial connection, and they had some sample code using libUSB to run it, which I looked at and ported to a Java library, which I call Wyong, which became its own open source project too. So anyone else who wants to use the push 2 from Java can use my Wyong library. Oh, it helps if I hook up the USB. Oh, that's there, the power. That's what you need, power. There we go. Let's do that again. So now I have this lovely graphical interface where you can see the metronomes going along there. Those are the beats, the bars, and the phrase going in the background. And the color effects, you can see the little color wheel there as you pick different intensities. So it's the same sort of stuff that you can do on the original push, only now with this awesome graphical interface. So for example, when you do a sawtooth dimmer effect, you can see the sawtooth wave right there, showing you the moment that's now, as well as the moments before and after in time. Or, oops. Oh, it's a torrent song. Let's do a piece of these. There's a triangle wave, a sine wave, a square wave, which just flashes on and off. That's it. Oops. Anyway, so that's the push 2, and I was really happy to be able to make that work as well.
So are you sending bitmaps 40 times a second to that thing?
That's exactly right. What Wyong does is it gives you an off-screen graphics context that is the size and shape of the screen. You perform whatever Java drawing operations in that you want, and then you call a function Wyong.sendFrame, which blasts it over the USB connection to the display. Wow. The off-screen buffer is structured to have the same bit arrangement as the screen does, so it's a pretty efficient operation to package it up and send it to the display. All right. Just a couple more things to show, and we will be done. Let's get this stuff. Okay. Let's do this guy. So I didn't really talk about this before. This is an example of a spatial effect. And what it does is it takes the dimensions of your whole lighting grid and assigns them all the colors of the rainbow. So you asked about this earlier. So we're going from a hue of 0, which is red, all the way up to a hue of 360, which is back to red. And the physical location of the light in space is what's assigning it that color. That's one way of doing color stuff. You can also do it over time. So this is shifting that over time, or just doing a rainbow over the whole grid. So those are spatial effects. And I want to show you, what I want to show you now is tempo synchronization. So that's why I brought the speakers in. Okay, Tractor, why are you not happy? Strange, I should be able to grab this controller and pick a different track, but it's not letting me, so we'll do it the other way. Oh, maybe because we haven't got that stuff. All right, whatever. So if we have this playing, I can sit here and tap the tempo. Let's say that. Oh, maybe it keeps the position. You can get pretty close that way. And actually, I think it worked through what's going on. I want to do an effect that is designed for picking, for helping with metronome synchronization. You can see better that you can get it kind of close, but it's not all that easy. And let me tell you, when you're doing a show for 12 hours and you're seeing the tapping tempo to try to figure out where the beats are and where the downbeats are, it gets tiring fast. So one of the early things I did was add this sync capability. And Afterglow has noticed that Tractor is running it. I've got this. I've got a custom mapping file that I wrote for Tractor that sends, in addition to MIDI clock, it sends messages telling Afterglow where in the beat it is right now, as well as which of the decks is currently playing. So Afterglow can figure out more profoundly, in addition to the tempo, exactly where in the beat it is. So once I do that, the beat can locks right into 150, which is what it is. And as soon as I hit tempo once, it'll be red on the downbeat. There we go. And so even if I go in here with the Tractor and start messing around with tempo, well, of course it gets to a part of the track where there isn't much rhythm. We will get back to this. That says that my is free. But even if I go and start messing with the tempo, Afterglow just stays right locked into it. So that is a much nicer way to run a light show. And let's kill you. So one last step. So like I said, we weren't going to do an actual light show, but I'll just show you a few of the pieces together that would go into making one. No.
Demo time.
Demo. So that was a very poorly executed demo of the lecture, which is why it's interesting. You think that preparing for a presentation and preparing to DJ were similar? They're not. You get into a completely different place in your head when you're going to talk about and explain something than if you're going to get up here and perform music. But hopefully you got an idea at least of what I was talking about there. So that synchronization with Tractor, which is nice because this is our much more portable gig, or portable gear. But when we're doing bigger shows, we use that gear there, which is Pioneer CDJs in a mixer, which is what you're going to see at any real festival or big club. And they don't synchronize in the same way as Tractor does, obviously, but they do talk to each other over Ethernet. And so I said, these guys sync to each other. I wonder if I can figure out how they do it. So I fired up Wireshark and started watching the traffic between them. And I was able to reverse engineer the Pioneer DJ Link Pro protocol, which is how they synchronize with each other. And now Afterglow is quite happy to eavesdrop on that and synchronize your light show to what the DJs are doing on their professional club gear. And that has turned into its own open source project this past month called, well, Dysentery is the first one. That's a yes, I'm glad people got that. That is a closure project which is designed to help probe the protocol and learn more about it. It just brings up windows showing you what's coming and what we think we know. That led to BeatLink, which is a Java library that implements what we learned from Dysentery. And then BeatLink led to BeatLink Trigger, which was used at the Electric Elements Music Festival in Canada and Ontario 4 weekends ago now to synchronize visuals on that big stage when the DJ was playing stuff on their CDJs, which was quite fun. And yeah, we're taking in other directions. Everybody wants to get the track metadata because the CDJs have, know the artist and title. So if you can see what's loaded up on the different CDJs, it would help you prepare your light show even better. I've gotten close. They do talk to each other. It's a TCP connection directly between the CDJs. So I had to get a managed switch so I could span the ports and see that traffic. I've gotten to the point where I'm replaying everything up to the point where they spit up the track info to each other, and I don't get it back yet. So I'm working with a guy in Portugal on that one, and hopefully we'll have that cracked soon, which will be awesome.
Does Tractor, the CDJs, have like metadata about the part of the song that you're entering that would be interesting for lighting?
There are cues, and I already have figured out how to do that. So when you're running the CDJs, you have those cue markers in the tracks, and then the DJ will have a cue marker on this player that's over here, and he's looking at this one ready to start the thing. You can watch the countdown. I can display the countdown in BeatLink Trigger or in Dysentery. And I'm going to add that to Afterglow. I haven't yet. I've been mostly working on BeatLink Trigger until I started preparing for this demo. Right. But that's going to be, getting the countdown in there and getting the track metadata. It's going to be super sweet. One last little gratuitous demo, and we're approaching the end. I talked about this being an integration hub for lots of different kinds of things. There's a protocol called Open Sound Control, which is like MIDI, only it's much more modern. It's network-based, so it goes over TCP, actually, or UDP. In addition to having a numerical value, you can have other types, strings, floats, integers, I forget what all. And there's hierarchical addresses, so sort of like you might have in your web application, different hierarchical paths. You can get or set hierarchically named things. So that's a much richer interface. And there's a program called TouchOSC. Let me set this up here, which runs on like an iPad. So let's review. I would turn you on. Let's go to gamers. Okay, so those two guys on the edges are being aimed by this aim cube here. And I've got TouchOSC running on this. Now, we'll see if this works or not. This is not my normal network that I use this for, so it could well, yeah, looks like it's working. So here I've got those two cues that turn on. I can turn those cues on and off with this. But this is the room we're in. Since it knows the dimensions of the room, I can say, here's the point in the room I want you guys to aim at. And they will just, like I said, it does the trigonometry to figure out how for each of those two lights, I get it to aim at that spot on the ceiling, or this is the height. So I say, oh, let's go down to the floor. So that is TouchOSC talking to Afterglow cues, and it worked.
So is TouchOSC is a product by the OSC folks?
OSC is an open protocol. TouchOSC is by a German company called Hexler. There's a lot of Germans involved here.
Okay.
Ableton is a German company. Tractor, Native Instruments is a German company. Hexler is a German company. They're really into this electronic music stuff. I think TouchOSC is like $5, $10 for your iPad now, for your iPhone. So it's not bad at all. And you can put whatever cue interfaces you want on there. I've got Sparkle Math as well. So, all right. So we're coming close to the end here. And this is just something I'm not showing you tonight. I mentioned we had another laser that I just didn't have time to set up and do all the safety tests for here, but I'll show you a little look at what it can do. This is our pride and joy. It's a 30,000 point per second RGB analog color mixing laser. And it has its own software package that controls it called Pango and Beyond. But Pango and Beyond can talk over a UDP protocol called Pango Talk. So of course I built Afterglow extensions to control Beyond from my Afterglow show. And yeah, with Haze, that thing is really quite a beautiful thing to do. All right, so that's it for the gratuitous demos. I just wanted to talk a bit more about how this relates to closure again. So you saw a bunch of effects happening there. What is an effect? Well, in Afterglow, an effect is a closure protocol, implementation of it, and that protocol has three methods. First, on every frame, we ask the effect, are you still active? Because it might not be, in which case we just remove it from the list of active effects. And we pass it, with any protocol, you pass the instance of the object you're calling, and then the show, because it might need to look at variables in the show, and that's where you store variables. And then snapshot is a metronome snapshot. So at the start of each frame, we take a snapshot of the metronome saying, what point in time is this frame rendered for? The reason we do that is if it takes a little while to think about the different effects across the grid, you want this light over here to be synced up with that light down there. So rather than using the actual now, we have them all run off the same snapshot. So if you're still active, we call generate, which we pass those things to as well. Generate spits back a list of assigners. I'll talk about assigners in a moment. And then if you want the effect to end, you call the end method, or end function in the protocol, and end can either return, yep, I'm done, or I can say, hold on a bit, I got a little cleanup to do. So your effect might have some sort of cool animation that runs as you're leaving. So those are the three effect protocol parts. What are assigners? Assigners are records implementing another protocol, and they basically are, I want something to happen. So it has a kind, which can be a channel, just set up a particular GMX channel to a particular value. A function, meaning like pick the sunflower-looking thing. A color. A direction, meaning point that way. Or aim, which is a little bit different than direction. Aim means point at that particular point. So if you assign two different lights the same direction, they'll both point the same way. If you assign them both the same aim, they'll both point at the same point. And then custom, you can build your own stuff. So that's how I pulled in Pango and Beyond that I was just talking about, or setting show variables, and things like that. So how that all works is there's a multi-method. So you've got these assigners, and then they're merged so that everything that's affecting the same object gets sorted by priority, and then whoever one wins, they run in order, and then each assignment can take what was coming before it and modify it if it wants to. So that's how the virtual dimmer works. It takes the color and then modifies it to dim it. And then in the end, there's a multi-method that takes that assignment and figures out how to turn it into DMX buffers to get blasted out to the lights. To build things that are real light shows, you need more than simple effects, and so there's some basic compounding things that you can use to put them together. A scene is just a bunch of effects, so whenever you run the scene, it runs all the effects. A fade takes one effect and smoothly moves into another effect. So that might be changing colors from red to blue smoothly, or changing direction from this to this smoothly, or changing from one scene to another scene. And then chases are basically fades that go between a lot of different effects. And then a blank is just nothing that happens. So you might have a part of your chase where nothing's going on. You can have them be conditional, you can have them set variables, you can build stuff up with that. So that's Afterglow as it is today. What possibly is there left to do? Well, I want to make more different kinds of effects, more different kinds of cues. I'd love to collaborate with a real lighting designer. I'm not. I'm a software developer who DJs. I have some ideas of how to make lights look pretty, but I have a bunch of friends who work in theater, and they're all super busy. But if I could work with one of them, take their knowledge of what looks great on stage with my knowledge of how to make it happen on the lights, I think we could get some really cool stuff going on. Another obvious direction is audio analysis. In addition to syncing up those other ways, you could actually listen to the music and figure out where the beats are and match the tempo that way. That's the easy part. The fun part is when you start doing fast Fourier transforms to figure out where in the audio spectrum the energy is, and doing visualizers like you see in iTunes. But having a visualizer across the whole lighting rig, that would be pretty cool. It's a different kind of visualizer. Afterglow already knows where all the lights are and where they're pointing and what they do. It would be nice to be able to get a preview so that I don't have to hook up all the lights and say, how does that effect look? Just render it so I can see it on my screen as an approximation. And I had some work in that direction going using WebGL, but the approach I took looked beautiful, but it kills the GPU. Because I was doing ray tracing through a field of the fog. Works great with 3 lights, with 10 not so much. So anybody who knows, is good with the graphics, I'd love to work with on that. I was thinking a smartphone app to help you figure out where your light is, because right now you have to you get out your angle measure and do some trigonometry in your head about, here's the normal orientation for the light, but it's hanging this way. What kind of rotations are there? That's the most tedious part of putting the show together. So if you could have your camera pointing at the light and it could recognize the feature on the light and then use the compass and accelerometer in there to figure out how the phone is oriented, it could do that work for you, which would be pretty slick. That's what I want to do. Anything else you guys want to see? All right, well, if you want to dig deeper, you can find all this stuff on GitHub. My GitHub account is BrunchBoy. And Afterglow is the main project. BeatLink is the other one I was talking about that's synchronizing with the Pioneer gear. Yhang is the one that draws the pictures on the push-to display. And that's my email address. So thanks all for watching.